In a groundbreaking development, scientists have successfully identified the presence of frozen water on the highest volcanoes within our solar system. Greetings, everyone. Today's video focuses on a remarkable breakthrough made by researchers. They have uncovered the presence of water frost on the tallest volcanoes of Mars, located near the equator. This discovery challenges our previous assumptions about the planet's climate. Although the frost is thin, it is quite abundant and only lasts for a few hours after sunrise. This finding provides valuable insights into the ancient climate patterns and atmospheric dynamics of Mars. Scientists are using high-resolution images to analyze and unravel more mysteries about the distribution of water and the potential existence of life on the red planet. Now, without any further delay, let us begin our discussion. According to a recent study published in Nature Geoscience, the team's findings indicate that frost has been observed near the equator of the planet for the first time, which challenges previous understandings of the planet's climate dynamics. According to Adomus Valentinus, a postdoctoral fellow at Brown University who conducted the research while studying at the University of Bern, the presence of frost around Mars's equator was considered unlikely due to the combination of sunlight and a thin atmosphere that maintains relatively high temperatures during the day. This is in contrast to Earth, where frosty peaks are more commonly observed. However, the current observations suggest that this phenomenon may be a remnant of a previous climate cycle on Mars, where precipitation and potentially even snowfall occurred on the volcanoes in the past. The findings of the study indicate that the frost, which dissipates when exposed to sunlight, is only visible for a brief period of time after sunrise. Despite its delicate nature, measuring a mere 1/100th of a millimeter in thickness, comparable to a human hair, the frost covers a significant area. Researchers have estimated that this frost contains a minimum of 150,000 tons of water, transitioning between the surface and atmosphere on a daily basis during colder seasons. To put this into perspective, it is equivalent to the volume of approximately 60 Olympic-sized swimming pools. In the region of Mars known as Tharsis, where the discovery of frost occurred, there exists a multitude of towering volcanoes. These volcanic formations surpass the nearby plains in altitude, reaching heights that are 1 to 2 times greater than Mount Everest on Earth. One example is Olympus Mons, which spans a width equivalent to that of the country of France. Thin patches of frost form within the calderas of the volcanoes, expansive depressions at their peaks that were formed in previous volcanic eruptions. The researchers hypothesized that the distinctive microclimate generated by the air circulation above these mountains is what enables the development of this peculiar frost. By studying the formation of frosts on Mars, scientists hope to uncover additional secrets about the planet, such as the distribution and movement of water, as well as gain a deeper understanding of its intricate atmospheric dynamics. This knowledge is crucial for future exploration and the ongoing quest to detect potential signs of life. By utilizing the high-resolution color images provided by the Color and Stereo Surface Imaging System, CASSIS, on the European Space Agency's Trace Gas Orbiter, the scientists were able to identify the presence of frost. To ensure the accuracy of their findings, they cross-referenced their observations with data from the high-resolution stereo camera on the ESA's Mars Express orbiter and the nadir and occultation for Mars Discovery spectrometer on the Trace Gas orbiter. To discover and validate the presence of frost on Mars, Valentinus undertook the arduous task of examining more than 30,000 images. By applying filters based on the location and timing of image acquisition, including factors like the time of day and season, Valentinus employed a methodical approach to pinpoint the specific spectral patterns that indicated the existence of water frost and its distribution across the Martian terrain. The analysis of the images began in 2018, with Valentinus devoting the majority of his efforts to this task during his time pursuing a PhD overseas. However, a portion of the reanalysis was carried out during his tenure at Brown University. As Valentinus embarks on his new position at Brown University, he intends to delve further into the enigmas of Mars, while shifting his focus to the captivating field of astrobiology. Under the guidance of esteemed planetary scientist Jack Mustard, Valentinas will dedicate his efforts to unraveling the nature of ancient hydrothermal environments that may have harbored microbial life. In the future, samples collected from these environments could potentially be transported back to Earth through the collaborative Mars Sample Return Initiative led by NASA. Valentinas expressed his enduring fascination with the concept of a second Genesis, the idea of life existing beyond our planet. To support our channel's growth and ensure broader awareness, kindly hit the like and subscribe buttons. This will help us reach more individuals and disseminate valuable information. Thank you in advance.